If I have Cartesian coordinate plane, I was to look at an initial side in standard position. If I go one complete revolution around, that would be my initial side and my terminal side are the same. Then that's one revolution. Now, I'm pretty sure if we were to talk about measuring this in degrees, everybody would know just from previous classes that they've taken. And that is one way that we can measure an angle, is in degrees. One revolution, everyone in here probably knows or has heard one time or another, is equal to 360 degrees. Just as a little added fact that's in the book, do you know why it's 360 degrees? I believe in the book it says because the Babylonian calendar had 360 days. So one revolution here, 360 degrees. We can also measure an angle measure in radians. And one revolution is also equal to 2 pi radians. And we can take the fact that we know that the Cartesian coordinate plane is divided into four equal sections, 4 quadrants. We use that fact to help us identify multiples of 360 degrees or 2 pi radians to get other angle measures in the Cartesian coordinate plane. I can draw an angle measure like this and actually figure out its measurement by using the fact that I know these are 4 equal pieces, the quadrants are. So if I go 1/4 of a revolution, how many degrees would that be equal to? That's right, you say 1/4 of 360. A fourth of 360 is 90 degrees. So what would that be in radians? If I take a fourth of 2 pi radians, so if it's 2 pi radians and I take a fourth of it, that's dividing it by 4. That will be pi over 2. So 1/4 of a revolution is equal to 90 degrees or pi over 2 radians. So that means 90 degrees is equal to pi over 2 radians, which we'll get into that a little later on. So what if I wanted to draw or sketch a 45 degree angle? Okay, let's think about that. Let's think about how 45 is related to what we just drew. How is 45 related to 90? That's half of it, right? So 45 degrees, or a 45 degree angle measure, is going to be half of what the 90 degree angle measure was. And since we know that a 90 degree angle measure is 1/4 of a revolution, a 45 degree angle measure would be 1/8 of a revolution, or just half. So if I sketch or I draw a ray that's halfway between the positive x and positive y axis, like that, then that would be an angle measure of 45 degrees, positive 45 degrees. Now, what if I wanted to draw a (180 degree angle? So first, let's think about what we know. We know that one revolution is 360 degrees. 180 degrees is half of that, right? So that means it's half of a revolution. So half of a revolution is equal to 180 degrees, which would also be what in terms of radians? That's right. If one revolution is 2 pi radians, half of a revolution will be half of that. So it'd just be pi radians. This is a special angle. It's called a straight angle. Okay, so here we would have theta equals 180 degrees or pi. So just by knowing one revolution is 360 degrees or 2 pi radians, that gives us the ability to draw a lot of different angle measures. You know, if I was to say 1/3 of a revolution, I would just divide the angle measure, the degrees, by 3. You say, what are you talking about, crazy person? If, say I want to draw a 135 degree angle, okay, how can I relate 135 degrees to what I know? You know, if I have an initial side here on the positive x-axis, if I go to the positive y-axis, that's 90 degrees. And then how much further do I have to go past 90? So you say 135 degrees minus 90 degrees, you'd have 45 degrees. And we know 45 degrees is halfway. So we just go halfway between the positive y-axis and the negative x-axis. Draw your terminal side. So that is an angle measure of 135 degrees.